have, from last time, because we haven't even started the calculus part, we only have just few things. Can anyone tell us just the condition? We don't need to solve it right now, but in order to find the domain of this function, f of x and g of x, can anyone tell us what is the condition for this, and then what is the condition for that?
Minus 3x must be greater than or equal to 0.
That's the condition we have to solve for that one. Awesome. And of course, I'm not going to do it, but you know it follows. Okay, good. And can anyone else say anything for this one? Anyone?
X minus 3 is not equal to 0.
Good. Perfect. What about 5 over 0? What does this mean?
Undefined.
Very good. Excellent. Don't let me skip letters and stuff when I write with uppercase. Sometimes it happens. Not very often, but it does. Sorry about that. I don't mean to, of course. And what about 0 over 0? It's another sophisticated word.
The indeterminate.
Yes. Indeterminate. So this is undefined, fixed, carved in stone, nothing. They will never exist. This, you will see in the next chapter, may exist. This one never. Will never exist. This one may. And you will see what what we're going to do with this in chapter 1. Awesome. I'm ready for your questions. Any questions? Anything you'd like to ask? Anything? If not, we go back to page 45. I should have everything in the background. Let me see. Yes. 45. Okay, I'm sharing my screen right now. Again, forgive me for what you hear in the background. So if I don't let this, and I can show you, if I don't let these notifications to come through, then I may miss something that you did, or maybe an email from you. So that's why I have to let these notifications come, and I delete them. But if there is an email, sometimes I get the notification, but I don't get the email. So I read it here. I don't have anything in my inbox. I have these 6 messages that I keep because I have some information in there before I archive them. Okay? So that's what I wanted you to. And if I don't delete frequently, in an hour I have like 150 messages or more. Okay? So when I go here, I delete them. Oh, I don't want to delete that. Okay, I just clicked and I moved some of them, and I have to be careful now and not to delete them. Okay, so we go back here. And I like to look at some word problems so we can go through especially profit or loss analysis. So let's start with 61. Anyone, any questions from Pearson or anything that you worked on, anything? Okay. So profit or loss analysis. Jamal decides to mow lawns to earn money. Okay. The initial cost of his electric lawnmower, so this is a fixed cost. Fixed. Well, let me write the page number also. I always try to be clear. Okay, so fixed cost, $250. Okay. Electricity and maintenance costs are $4 per lawn. Be very careful. Oops. So this is, it doesn't allow me to highlight. Fine. So these are variable costs. So 4 per lawn. That's why this is so important to always write the measurement unit. I cannot stress enough. Write the measurement unit. Formulate a function C of x for the total cost of mowing x lawns. So in part A, total cost. And the total cost function is C of x. So I don't know if you remember, but the total cost function, total cost, is the sum of the fixed and variable. I like to put the variable and then fixed. So variable costs plus fixed. The fixed is very clear, right? It's 250. But how do I express the variable? So this X is the number of lawns that he will mow. Okay, fine. So how do I express the variable cost? Anyone would like to help with the variable cost? It's okay if you're wrong.
Wouldn't the C of X equal 4X plus 250?
Exactly. Perfect. So it's $4 times the number of lawns that he's going to mow. So then we have C of X, which is indeed 4X plus 250. And that was Donna? Carmen, thank you very much. Perfect. This is part A. I'm going to share my screen and let's look at part B. Jamal determines that the total profit function for the lawn mowing business is given by, okay, in part B, we have P of X, total profit, 16X minus 250. Find the function for the total revenue from mowing X lawns. How much does Jamal charge per lawn? Okay. So does anyone remember what is the relationship between revenue total profit, and total cost? Anyone remembers the relationship between total cost, total profit, total revenue?
I think it's revenue equals profit minus cost.
Good. So profit, revenue, you said the same thing in a different way. So the total profit is always money coming in minus the amount that goes out. So always revenue minus cost. Or if you want to say revenue, then you have to put plus. I'm not sure if you said plus or minus, it doesn't matter. I just want it to be clear. So the total profit is money coming in minus the cost. So we have the profit function. We have the cost function. They are asking us to find the revenue. All I have to do is when we move a term from one side to the other, we only change its sign. So the revenue will be the profit plus the total cost. Stop me anytime. This is not a monologue. Please, any questions? Any questions? Okay, so revenue. They're giving us the profit, 16x minus 250. I have to add the cost function, plus 4x plus 250. Awesome. I'll move this out of the way for now. 16x plus 4x, 20x. Now remember the last question, part of the question. How much does he charge per lawn? Can anyone tell us? So this is the revenue equals 20x. From here, can anyone tell us how much he charges per lawn?
He charges 16.
So if the revenue for X lawns is 20 times X, then he's charging 20 per lawn. 20 times each. If he mows 1, he gets 20. If he mows 2, 40. 3, $60, and so on and so forth. Is that clear?
It's a little confusing because in A, I thought that he charged it was $4 per lawn.
Oh, I see what you mean. It's
Hold on, hold on, hold on,
I'm
just
sorry,
one second. This is his cost. This is for the electricity per lawn, or whatever else is involved.
Oh, okay,
This
okay.
this is the cost.
I got you.
So how much he charges will always be related to the revenue. Is that better?
Yes.
Perfect. Perfect. Okay. How many lawns must Jamal mow before he begins making a profit? So we know that there is something called, so this is part C, break even point. Anyone remembers what the break even point represents? When the profit equals
Cost.
0, or the revenue equals the cost. So the break-even point can be determined either saying profit equals 0 or saying revenue equals the cost. What does it mean? Money coming in is all spent, no profit, or profit 0. Regardless of which one you prefer, it doesn't matter, it's the same thing. So I go back to the profit function. Here's my profit function, 16x minus 250. I set it equal to 0 to find the number of units needed to say, okay, after we finish this one, from this point on, we will start making profit. So I take one term that is negative to the other side, 16x equals 250, and divide both sides by 16. And lazy people who use a calculator, I'm one of them. No, I'm kidding. 15.6. So since he cannot mow 15.6, I'm going to say 16 lawns. So from the moment he finishes the 16th lawn, he will start making profit. From here, his profit will become more than 0. Before mowing 16, he is in the minus. He's not covering his costs. He didn't even get to have profit 0. But at 16, his profit is 0. So from this moment on, he will start making money. Any questions? And these are all linear functions, of course. Any questions? Okay. Let's finish up this chapter. And I'd like to continue. The last section deals with, it's R.5, nonlinear models. So I am going to go to page, which page? 60. Where's my keyboard? Nope, not 90, 60. Okay. So I just want to look at few situations and then we'll choose. Okay. So first thing that I would like to go back to is analyzing these formulas, because we're going to use these formulas a lot. These are called exponential rules from 45 through 68. I will list the rules for you and then we'll come back and work on these problems a little bit. So let's talk about exponential rules first. And that's my page 3. Exponential rules. There are many exponential rules. So for example, a raised to nth times a raised to mth. I know it's confusing, I'm sorry. 2 bubbles, 3 bubbles, n, m. We copy the base. We never touch the base. We don't multiply, we don't add, nothing. Just copy the base and add the exponents. N plus m. Next one. A to the nth power over a to the mth power. We copy the base and subtract. And it's always in this order. From this, we subtract this. From n, we subtract m. A to power n, everything to the mth power. Anyone remembers this one? Anyone I haven't heard from, so please contribute even if you don't remember. I haven't heard from Jack, Ali, Joan, Natalie, Kenya, anyone, please. Just show me that you are here.
I don't remember.
Is it
Professor, what did you,
A n times m?
Yes, very good. Awesome. Good. It's okay if you don't remember. Now you will. Okay. A to a negative power. Anyone remembers this one?
One over a.
Very good.
yeah,
Excellent. Excellent. Thank you. You do remember. Awesome. Okay. Now, I would like to go to something that is maybe more difficult to remember. So the nth root of a to the mth. And you can say, what is this? How is this connected? How is this connected to exponential rules? This is a radical. What are you talking about? So, well, any radical is basically an exponent. Copy the base, and the power is a fraction. So, Alex, you are more than welcome, but this is not your class, just so you know.
It's
So,
my I'm sorry, it's Hoover. For some reason my Zoom's using my email instead of my school ID.
oh, okay, because I have an Alex in the other class. Okay, maybe he's your
Yeah.
brother. Is he your brother?
No, no.
With the same last name?
Oh, really?
Yes. So the nth root of a to the mth is a raised to a fractional exponent. The exponent is a fraction. This is always the numerator. The index is always the denominator. So we can go back and forth. All of them, we can go back and forth. From here, here, from here, back. From here, here, from here, back. From here, here, and back. All of them. The same thing here. So this is one of the most important here. We are going to use this a lot. And